Hello one last time for this series, and we'll close off with the other big example in class regarding flow, which is how do we get the most stuff across this network? We did it by hand. It was not that bad. We ended up with a pretty straightforward process where we just found a route and worked everything across that route, and we just kept picking routes until we couldn't pick any more routes that had stuff to move across. And that was fine for this 6-node network, but what if our network had 60 nodes? It starts to get impractical to do it by hand, even though the process is still very simple. But what's good at doing simple processes is, of course, Microsoft Excel. So I have here the same information as here. I've got all of the routes with their respective capacities, all the non-zero ones anyway, and I want to get as much stuff into node 6 as possible. So then I suppose that means I need to sum if this stuff coming in is equal to 6, and if it is, I should sum up how much is actually flowing. Currently nothing is going in, but that's what I want to get as big as possible. So let's see here. We can basically do the same thing, except now we're going to have stuff coming in and stuff leaving. Right? Nothing's going to leave our destination. But let's see here. Let me go ahead and copy paste this, but first let me fix it so it won't budge. Okay. So I've got sum if, so this is all my arrivals, and I want to subtract from that all of my departures. So doop. And instead of it being the B column, which is for arrivals, we'll use the A column for departures. And I'll fill that up. So I think that's ideal, except I'm missing now just these values, which is how much can go across each route. But I can just make that my own constraint set. So I believe we're good to go. So I'm going to pull up Solver, undo all of this garbage, and I want to maximize what is going into 6. And I'm going to do that by changing my branch flows. I'm going to have the constraints that all of this stuff has to equal 0. And all this stuff cannot exceed their capacities. And I'm going to click solve. And 15 was the solution. And wouldn't you know it, 15 was the solution we found by hand, and we found it far faster. And actually, this is a far simpler setup, and for Solver, a simpler solution than what is posited in the text by your author. It does the same thing, but it doesn't have any of this weird fancy footwork. Actually, now that I look at this, the writing is the same, but the way your author went about doing it through Solver was different. So hopefully this clears up some of the processes here. Hopefully this gives you a hint as to how you might be able to use Solver quickly on some of your assignments going forward. But that is it for this section. Sum if. It's a wonderful thing. So let me know if you have any further questions. Thanks so much, and I'll see you up ahead.